Okay, so like Paul said, I'm going to share the data quality dashboard, but I'm really honored to be here because I am not a developer, and I think you'll see as we go through this, I was not trained as a developer. My bachelor's degree is in biology, and I have a master's degree in public health. So I'm not a computer scientist. But I think that's I'm a really good test case because if you are new to the community and potentially even new to development, I think the data quality dashboard probably has the lowest barrier to entry, and B, any expertise you have, we can either work with you to see where it will fit in many of these tools that are being presented today, but we can also help you learn and grow in those areas that you are interested in. So I think for me, I've learned a lot about R through this process of helping to lead the DQD. All right. So I'm going to go a little bit through the project history. I'm going to take you through what is the data quality dashboard. I'm going to share with you the code base, but I'm actually not going to show you a ton of code because it's actually a pretty simple package. But the way it works is a little bit different, I think, than some of the other presentations we're seeing here today. And then I'm going to take you through some options for contributing. I don't have a cool live demo like Maxim and Sena, but I do have some other things to share that won't just be PowerPoint. Okay, so we developed the DQD, which is short for Data Quality Dashboard, in 2019, and it was presented at the Odyssey Global Symposium that year. The initial team included Frank DeFalco, Ajit Londe, and Anthony Molinaro, but we've since expanded. Maxim is actually a major contributor in the DQD, as are a couple other people on the call. Like I see Luis and Roger and Matthew, so good to see you guys. Now, this was developed in response to a need that was described by the FDA, detailing the gaps in the current data quality procedures for regulatory purposes. I actually went to a workshop held in DC by the Duke Margolis Institute. It was me and Patrick and Andrew Williams. And after we were there, we sat down in a booth and we're having some drinks and some lunch. And we kind of came up with this idea for the DQD, and they let me run with it. And that's kind of where we are today. So it was kind of cool. And what we set out to do was to create a unique standardized data quality tool that didn't make us write thousands of SQL statements, but would still meet and hopefully exceed the needs of regulators, as well as allow us to expand it easily in the future. So, a lot of times when we think about evaluating a database for quality, we think about those individual SQL statements we would write to test one individual thing that we're looking for, like people with crazy birth years or visits that end before they start, that kind of thing. So what we wanted to do was figure out a way we could standardize that process and make it easier so we didn't have to write thousands of those SQL statements. So what we came up with is an R package. So it's a pretty lightweight R package, and it generates over 3,300 SQL scripts on the fly. And what I mean by that is as the package is running, it generates those SQL statements as it goes. So when you look in the package, it looks like there's only, I think now 21 SQL files, but those 21 SQL files expand to thousands of different individual data quality checks. And once it's done, it outputs a JSON file, which is just a text file with all the results. And those results are then read by a Shiny application. So it's meant to be self-contained. It's meant to kind of work independently. Its only dependencies are really SQL render and database connector. But we wanted it to be as lightweight as possible. So the idea is it's probably one of the first R packages that a newcomer to Odyssey might be using once they get their data into the common data model. Okay, so I like to begin with the end in mind. So I just wanted to give you guys a quick overview of what the Shiny application actually looks like, just really quick, just so you have an idea of what is our end result as I go back through the code base. So this is our Shiny application. It's actually Shiny wrapped in Java. So I've made like a couple little edits to the Java over the years, and I was very proud of myself because I do not know Java. So as you can see, we had an overview that showed the total number of checks that pass, the total number of checks that fail, that kind of thing. And as you go down through the results, we've got one line per check that was run. And as you expand it, you can actually see the SQL that was generated for each check. And it tells you, the number of rows that violated that check. And then it also tells you the execution time. And this is something we added in later on because we found that some checks are taking a lot longer than others. And so this helps us to evaluate where we need to spend some of our time trying to optimize those queries like Barack was talking about. Okay. All right, so back to here. So a lot of times, if you guys have seen me talk about the data quality dashboard in the past, you'll recognize this slide. I talk a lot about, you have to input the data quality checks you want to run. You have to input the thresholds against which those checks are going to be evaluated. So, if 10% of the records in a table violate a certain check, is that passing or failing? And that's where you would set that threshold. But this is kind of a simplified version. So what it really looks like in terms of the code base is we have this set of control files. And the set of control files are actually CSV files. And these control files tell the execute function which SQL templates, because of course we're generating them on the fly, it tells them which SQL templates to pull up and how to run them. So what we've done is we've made use of SQL render, and we've generated these SQL templates that are then used to write those SQL statements as the package runs through. And I'm going to take you through kind of how that works, but as an overview, this is what it looks like. They both go into the execute function, and then that execute function will run the checks, evaluate them, add the thresholds on, tell you which is a pass or fail, and it'll output all that to a JSON result object. So I'm going to come back to this, but this is like a very high level view of what the package is doing. And if you guys have any questions as I go through this, please don't hesitate to ask. So,
I do think it's really powerful. Oh, go ahead. I think this is a really powerful point, is that it actually is being driven by an Excel file for actually configuration management. And I think that really is, I thought that was on the left-hand side of your tech stack of going from Excel to R to SQL to your website. But
oh, that's a good point. I could probably add that in there. I didn't even think about that. I could probably put like a little Excel icon there. Okay, so the way the control files works, there are 4 control files per CDM version. And that's really important because each CDM version is slightly different. And we have to make sure we are looking at the correct configuration of tables and fields as this goes through. So the main control file that actually handles what the checks are and what SQL file is associated with each data quality check is actually called the check descriptions file. So if we take a look here, the way this works is you've got your check names here in this column called check name. You'll also hear us talk about these as high-level check types, because these aren't individual data quality checks, but they're essentially a data quality idea that we are going to apply across the CDM to different tables and fields. And you can see here, I didn't expand the check description because they're a little bit large. But if you are interested in what these checks are and the check descriptions, they are out on our website, odyssey.github.io, under articles, data quality check type definition. So if you're interested as I go through these, feel free to take a look there. Okay, so we've got your check names here, and then you'll see here that there are SQL files listed for each one. So each one is associated with one SQL file. And there's also this evaluation filter. And this is what it's going to be looking for in the rest of the control files to know, okay, when I see a yes in a certain column, then I know I need to pull up this SQL file and create a single SQL statement. And so I'm going to show you how that works as we go through here. Okay, so let's see, I'll go back here. So the first one is table level check. So we have organized our data quality checks into table level, field level, and concept level. And these are really important to understand how the SQL is working and then how they are organized. So the table level checks are checks that are evaluated within a single table. So for example, really the only one we use right now is called measure person completeness. And what that does, it actually goes through and it looks to see how many people actually have a record in each of the table names listed in column A. But you'll see here that measure person completeness is listed in column E. So what the function is going to do, every time it sees a yes in this column, it goes back and says, okay, I now need to call up that SQL file. Oops, that was not what I meant to do. It says, I need to call up that SQL file I had listed here. So let me see if I can go back. Yeah. So it says, oh, I see a yes in measure person completeness for observation period. Now I know I need to call up this person completeness.SQL and write one SQL statement for that table. All right. So as we go through field level, then it gets a little bit more complicated. So field level checks are going to look at individual checks for both a table and a field. And this is where they might also relate to other fields in the common data model as well. So you'll see here, this is why we have one set of files per version of the CDM, because we list out literally every single table and field. And then we've got check names across the top. And as it goes through, it's going to start evaluating and running each of these different checks for each table and field in the CDM. So if you take a look here for person ID, for person and care site ID, we are going to evaluate the is foreign key check. Now this check is going to call up the SQL file related to is foreign key. And then we've also got some values here that the SQL file is going to use to actually write that SQL statement. So this is where SQL render really comes in. And this is where, if you're interested in helping us develop DQD, if you are really comfortable with SQL, this could help you also get used to SQL render, which is one of the underpinning packages that goes through pretty much all of our work here in Odyssey. And so SQL render allows you to pass through different parameters, and it will take in care site and care site ID as a parameter, and it will write that SQL statement out. So if you see here, we've got back in the check descriptions file, it says, okay, for the check name is foreign key, I know I need to bring up the is foreign key.sql statement for everywhere it has a yes in that column. It then pulls up the SQL template, which is going to be, and I'll show you the file structure in a moment, but it brings up that SQL template. And you can see here, this is the SQL render portions. These @ symbols here are looking for parameters to fill in based on what's in these CSV files. And once it finds it, like person.caresiteID, where we're going to evaluate the foreign key relationships between person.caresiteID and caresite.caresiteID, it fills in all those values that the SQL template wanted. And now this is an individual SQL statement. So that's really how it works. It goes through all these different files and they work together to develop all of these SQL statements as the package runs. And there's some values and some things you can do in the execute function, so you don't have to run all of them. But I feel like this is a really good place to start for the DQD, because if you don't understand this process, it's very difficult to actually understand the R code that's in the package itself. Okay, so the last one is the concept level checks. These work very similarly to the field level checks, except that they are evaluating individual concepts. So you can see here, we've got Billy Rubin, and here's the concept ID associated, and it's going to look at records that have that concept ID and this unit concept ID. And then it's going to start to evaluate the values of those measurements. But it's a very similar concept, very similar idea as to what we're doing in both the table level checks and the field level checks. It just goes, one more step down in granularity to individual concept IDs. Okay. So once that's done, and you kind of have all this kind of background knowledge, the execute DQ checks function puts it all together. So what that function does, it's going to check your inputs and your metadata. It's going to load in the control files, and you can either use the ones that are defaulted in the package itself, or you can change them up a little bit to make sure that you have the proper thresholds you want, and you can actually add some metadata and some notes in there. So once those are loaded up, it's going to run the checks, it's going to evaluate the thresholds, summarize the results, and then write it out to a JSON. And then once that JSON is written, we have a function called view DQ dashboard, where it's going to take that JSON and pull up the Shiny application. And those are honestly the two main functions in this package. Like I was saying, it's a really lightweight package, but it does quite a lot on the back end. All right, now let's get down to our development needs. So we actually had a DQD call yesterday, and we went through and talked together about where we saw our needs and where we think we could help newcomers to the community potentially learn. As I was saying, I think this package probably has the lowest barrier to entry if you want to start contributing to any sort of development. All right, so I've broken it down into SQL needs, R needs, user testing, and then if you are not a coder, but you would like to contribute, we actually have a lot of opportunities there as well. So in SQL, if you are very good with SQL and you want to learn maybe SQL render and also how to spin up a synthetic data set, we have a lot of new checks that need SQL templates. We've been meeting quite regularly as a group, and we've identified quite a few new checks. And these need some SQL templates. And I'll show you in a minute on the GitHub where these are so you can find them. And then there's also some enhancement related to the SQL templates or bug fixes too. So a really great example is Maxim recently identified an issue with one of our checks that perhaps we weren't using the proper denominator. And so in that case, we don't need a new SQL template, we just need to fix a current one. But still, if you are a SQL wizard, we could definitely use your help. Okay, in terms of R, we would like to get the package into Hades, and Hades is a collection of packages in Odyssey that all comply with a certain set of rules that are all packaged together, and we really would like to put DQD into Hades, but we need some help formatting the package to comply with the requirements. Like a big one is we do not have continuous integration testing. I honestly, I'm not, as I said, I'm not a developer. So if someone knows how to set up continuous integration with GitHub Actions, that would be fantastic. Adam Black helped us with it for the Common Data Model package, but I'm still not quite certain if I can follow his example. So we would love if someone knows how to set up GitHub Actions and is familiar with R in that way. And we also need to update to the current Odyssey best practices for packages. So if you are a wizard in R and you want to learn about Hades, you are welcome to be our Hades representative and help us get to this goal by the end of the year. Okay, so we also need some user testing. So as I mentioned, Luis is on the call. I'm hoping Dimitri is too. They have been working very hard on our version 2.0. We've updated some of the ways that the results are evaluated in the DQD, and Luis has been working on a new fully shiny viewer, meaning it is not wrapped around Java. It is a full-blooded shiny application, because we want to look like everybody else on the block, and we want to have a full shiny app. So Luis has been doing a lot of work there, but we need some user testing. So if there are any folks who are new to the DQD, or even just new to Odyssey and want to learn how to run their first R package, this is a really good opportunity for you, because I've actually had a lot of folks who I've worked with. I think Nitin is on the call. He and I have worked together to help him get up with a synthetic data set and have him running DQD, and now he's running it for Stanford. I've had a couple other folks contact me, and so this is a really good way to start to learn about the community, but then also help us with testing. And then finally, we have some non-coding needs. So we've got some documentations. If you'd like to help us write a vignette and maybe you want to learn how to write in R Markdown, we can certainly set you up there. We need some documentation review. So are the things that are currently out on our website, are they still true? Because as we all know, as we can start to update our packages, we don't always update the documentation accordingly. And then we've also need some help validating measurement unit pairs. So in that last control file I showed you, we've got those measurement concept IDs and unit concept IDs and plausible values that we're using to understand if measurements in a given database have values that we could potentially use in a study. However, as I will show you on our issue page, it seems that they're not always, we may have some incorrect values in there. I'll just try to put it nicely. And so this might require access to data, or you can work with someone who has access to data. But if you are willing to help us validate these measurement unit pairs and help us, understand what values we should have in there, that would be super helpful. It's a big task, but it would be a huge win for everyone in the community. All right, so let me just show you here. So one thing I just want to quick go through how to contribute, but let me pull up GitHub because I think I'm almost out of time. So really quick, I want to just show you where you can find all these issues on the GitHub. So if you go to github.com/odyssey/data quality dashboard, we've got issues over here. And I tried to add some labels kind of like Maxim did, but more associated with the skill sets I was talking about. So I tried to tag things with SQL So if you click on the label, it'll bring up everything that is related to SQL, like maybe writing a new check or updating existing SQL statements. And then if we go back here, I've got some that are listed as no coding. So as I was saying, these are some of these measurements that might have incorrect values in those control files. So this does not require any coding skills, but if you are familiar with measurements or if you have some clinical knowledge, this would be super helpful. Then I've got a couple under R. And then I think we have some user testing, but it would be related to our pull request. So if you see here, we've got this pull request version 2.0. I know Maxim and I have been testing, and a couple other folks have been helping to test. And so if you're interested in helping to test, we can get you set up and show you how to actually open up this pull request so that you can run it in your own environment.
Claire, you've got a great use of labels. I really like your labeling on your issues. I think that's the best practice. It would be also fun if you could add a label for like good first issue for people looking for that list saying, hey, which is the one that's really good to start off with?
Okay, I can definitely do that. We also have two. I've tried to be good about setting up projects so we know where we are. So we are really focused on version 2 this year. We'd like to have this released before the global symposium in October. I'm hoping we can have a table, one of the demo tables where we can show all the new features, because you know, Dimitri and Louise have really been working very hard, and we're really excited because we think version 2 is going to be much easier to use, and we've really taken in a lot of the feedback we've gotten over the last few to really enhance the tool. So if you are interested in what we are focused on for version 2, it's under projects, and you can see I have some of these issues out here under features and new checks, and we're continuing to add things as we meet together. And so one last thing on how to contribute, very similar to what Maxime went through, similar to what Anthony went through. You want to either open an issue or take on an existing issue. And as I went through, we have those labels out there. Either fork the repository, you could also clone the repository and make the changes in your local environment. Then you would once you're happy with your changes, open a pull request to target the develop branch. So that's one of those things that I was talking about where we want to start to comply with the Hades requirements, where we have all of our current code on the main branch and everything that's in development on the develop branch. So once you can open a pull request and target the develop branch, someone from the DQD team, likely either myself, Maxime, Frank, or Anthony Molinaro, we will review and provide you feedback. And then after we all agree, your changes are pulled in and released in an upcoming version. I do want to offer, though, you know, if you are new to GitHub and this might be your first time walking through this, I'm happy to help you. We also tend to try to go through this on our calls. So we do have calls every other Thursday at 10 a.m. Eastern, and you can find that on the workgroups page at odyssey.org. And we try to be very open and welcoming, and we go back through a lot of these basics every time so that everyone knows where we are.